2 hours. That is the total error. A civilization without telescopes, without glass lenses, without metal instruments of any kind, tracked the orbit of Venus across 500 years and missed the mark by 2 hours. Not 2 days, not 2 weeks, 2 hours. Less time than a delayed flight from Dallas to Denver. And when 21st century astronomers fed the same orbital parameters into computer models, they confirmed it. The Maya were right. You have probably stood at the base of a Maya pyramid, maybe Chichen Itza on a cruise excursion, maybe Tikal if you were more adventurous, maybe the Pyramid of the Sun at Teotihuacan on a day trip from Mexico City. You looked up, you felt the scale, you took the photograph, and someone near you, a guide, a fellow tourist, a half-remembered documentary, said something about how mysterious it all was, how we still don't understand how they did it, how maybe they had help. They did not have help. They had patience. They had mathematics. They had a number system more sophisticated than anything Europe would use for another 8 centuries. And they had time. Generations of astronomers passing observations from teacher to student, father to son, priest to apprentice, building a dataset that spanned centuries the way a modern research institution spans decades. What they built with that patience is not mysterious. It is documented, it is published in peer-reviewed journals, and in several specific cases, it has been verified only in the last 10 years. Here is what the record shows. The Dresden Codex is a Maya book, not a stone tablet, not a wall carving, a book made from fig bark paper beaten thin and coated with lime wash, then painted in carbon black and cinnabar red, accordion folded so a reader could open any section without unrolling the whole. It dates physically to the 13th or 14th century, but the astronomical data inside it is far older, compiled from observations stretching back to the Classic period, perhaps the 7th or 8th century. It sits today in the Saxon State and University Library in Dresden, Germany. It survived because it was sent to Europe as a curiosity before the burnings. Inside this book is a table tracking Venus. The Maya astronomers knew Venus's synodic period, the time between successive appearances as the morning star, was approximately 584 days. Modern calculation puts it at 583.92 days. That difference of 0.08 days would accumulate over time, drifting the table out of alignment with the actual sky. The Maya knew this, so they built a correction mechanism into the table itself, periodic subtractions at specific intervals that pulled the prediction back into alignment, functionally identical in principle to our leap year system. Over the table's full recyclable span of 481 years, covering 65 complete Venus cycles, the accumulated error amounts to roughly 2 hours. In 2016, Gerardo Aldana at UC Santa Barbara published an analysis arguing that this was not mere observation, but active scientific correction. The astronomers who maintained this table understood that their base period was an approximation. They understood the concept of systematic error, and they built the fix into the mathematics. This is not mysticism. This is science, conducted without a single piece of glass or metal, across generations that never broke the chain. Now consider what made that mathematics possible. You learned to count in base 10. The Maya counted in base 20. And within that system, they did something that seems simple until you realize how rare it is in human history. They invented zero, not a vague philosophical concept of nothingness. A functional, positional zero. A placeholder that allowed their number system to express any quantity, compute any date, track any cycle. The earliest documented Maya zero appears on a stela at Chiapa de Corzo, dated to 36 BCE. Europe would not widely adopt zero until Fibonacci published his Liberabaci in 1202, drawing on Indian mathematics transmitted through Arabic scholarship. The Babylonians used a placeholder symbol by 300 BCE. The Indians developed full arithmetic 0 by the 5th or 6th century. But the Maya did it independently, in complete isolation from every other mathematical tradition on Earth, with no contact, no transmission, no borrowed idea. They solved the same problem the rest of the world solved, but they solved it alone. That 0 was not decorative. It was load-bearing. The Maya long count calendar, a continuous day count starting from a base date in 3114 BCE, could track periods spanning millions of years. Inscriptions at Palenque reference dates 20 million years into the past. This is not ritual exaggeration. The mathematics works. Each date computes correctly within the vigesimal positional system. The Maya conceived of deep time on a geological, cosmological scale. 1,000 years before European geology would formalize the concept. Their eclipse table fills another section of the Dresden Codex. It spans 405 lunations, approximately 33 years, and identifies what scholars call eclipse danger zones, windows during which a solar or lunar eclipse becomes possible somewhere on Earth. Modern astronomers have checked this table against retroactively calculated eclipse dates. The table catches virtually every possible window. It does not predict which eclipses will be visible from which location. That requires understanding the Saros cycle's geographic variability, which no pre-telescopic civilization fully modeled. But it identifies when an eclipse could happen, and it is right again and again across its full span. So here is a civilization tracking Venus to within 2 hours, predicting eclipse windows across decades, computing dates millions of years forward and backward, and doing all of it with dots, bars, and a shell glyph for 0, painted on bark paper in a tropical forest. And they were also engineering their water supply in ways we verified only 4 years ago. Tikal. At its peak, between 600 and 800 CE, this city held 60 to 80,000 people. It sat in a seasonal tropical landscape with no rivers, no lakes, no permanent water source of any kind. Every drop the city drank came from rain, captured and stored in an engineered system of reservoirs, channels, and dams. Vernon Scarborough's archaeological work documented at least 7 major reservoirs with a combined capacity exceeding 900,000 cubic meters. The plazas themselves were designed as catchment, sealed plaster floors angled to channel runoff into specific collection points. But capturing water is not the same as keeping it clean. In 2020, Kenneth Tankersley and his team at the University of Cincinnati published a study in Scientific Reports documenting what they found in the Corriental Reservoir at Tikal, a filtration system using zeolite and coarse crystalline quartz sand. Zeolite is a crystalline mineral that functions as a molecular sieve. It traps bacteria, heavy metals, nitrogen compounds. It is used in modern municipal water treatment plants today. The Maya transported this mineral approximately 30 kilometers through dense jungle from the Bajo de Azucar region to install it at Tikal. They did not stumble onto it. They went and got it. Tankersley's team analyzed the mineral composition and confirmed that the zeolite quartz combination would have effectively removed harmful microbes and contaminants. The engineering principle is sound. It works, and it predates any documented water purification system in the Old World by approximately 1,800 years. They built a city of 80,000 people where there was no water. Then they engineered the water. Pause with that for a moment, because the scale is about to shift. In February 2018, the Pacunam LiDAR initiative, fired laser pulses through the jungle canopy of Guatemala's Petén region and mapped what lay beneath. The results, published in Science, revealed approximately 61,000 previously unknown structures across a survey area of 2,100 square kilometers. Raised roads called Sakbiob connecting cities across swampland, extensive agricultural terracing, massive defensive fortifications, quarries. The jungle between known Maya cities was not empty. It was infrastructure, dense, connected, engineered. Marcello Canuto, the project's lead researcher, put it plainly. Most scholars had been comfortable with population estimates of around 5 million for the Maya lowlands. With this data, estimates of 10 to 15 million became reasonable. The equivalent discovery in Europe would be finding that the countryside between London and Manchester was not open farmland, but continuous suburban development, hidden under 1,000 years of forest growth. The Maya lowlands were not scattered city-states in empty jungle. They were a civilization operating at a population density comparable to medieval Europe. And we did not know this until 2018, because the jungle hid it and because earlier scholars underestimated what they could not see. Then, in 2023, another piece fell into place. For decades, Mayanists had puzzled over a recurring cycle of 819 days found in inscriptions at multiple sites. It did not align neatly with Venus, or the solar year, or the lunar month. It seemed ritual rather than astronomical. John Linden and Victoria Bricker published a paper in Ancient Mesoamerica demonstrating that when extended to its full cycle of 45 rotations, approximately 45 years, the 819-day count aligns with the synodic periods of all 5 visible planets: Mercury, Venus, Mars, Jupiter, and Saturn. The Maya had integrated the cycles of the entire visible solar system into a single, unified mathematical framework. European astronomy did not achieve a comparable unified planetary model until Copernicus and Kepler in the 16th and 17th centuries. The Maya did it with naked-eye observation, bark paper codices, and a number system built on shell-shaped zeros. And here you need to hold 2 facts simultaneously, because they belong together. The Maya produced thousands of codices, thousands of books containing astronomical tables, histories, genealogies, ritual calendars, agricultural records, mathematical computations. We know this because the Spanish told us so, and then burned them. In July 1562, Bishop Diego de Landa ordered the destruction of Maya books at Mani in the Yucatan. His own account survives. We found a large number of books in these characters, and as they contained nothing in which were not to be seen as superstition and lies of the devil, we burned them all, which they regretted to an amazing degree, and which caused them much affliction. Of thousands of codices, 4 survive: the Venus table, the eclipse predictions, the Mars data, the 819-day planetary framework. Everything we have verified in the last decade comes from a fragment of Maya intellectual output. The precision that stuns modern astronomers represents what happened to survive a deliberate campaign of destruction. Consider what was lost. The 19th century explorer John Lloyd Stevens, standing at Copan in 1841, wrote that the city lay like a shattered bark in the midst of the ocean, her masts gone, her name effaced, her crew perished, and none to tell whence she came. It was a beautiful sentence, and it was wrong in almost every particular. The Maya had not perished. Their cities were not nameless. They had names in hieroglyphs that scholars could not yet read, and there were people to tell where they came from. They were standing nearby, speaking Maya, watching Stevens sketch their ancestors' buildings. The decipherment of Maya hieroglyphs largely achieved between the 1970s and 2000s through the work of scholars like Linda Sheila and David Stewart, gave those glyphs back their voices. We can now read the names of kings, the dates of wars, the records of eclipses observed on specific days. The Maya wrote their own history. We just could not read it for 4 centuries. You ate their science this morning. The corn in your cereal, domesticated from teosinte through selective breeding that took thousands of years. The chocolate in your coffee. Cacao, first consumed as a bitter drink beaten with chili and vanilla. A Maya preparation. The tomatoes in your salad. The vanilla in your ice cream. The avocado on your toast. The chili in your hot sauce. Every one of these was domesticated in Mesoamerica by peoples whose intellectual achievements we are only now fully documenting. And here is the fact that reframes everything. Over 6 million Maya language speakers are alive today, across Guatemala, southern Mexico, Belize, and Honduras, speaking more than 30 related languages. The classic Maya political system collapsed in the 9th and 10th centuries. Cities were abandoned, dynasties ended, populations redistributed. But the Maya as a people did not disappear. They continued. They are not a lost civilization. They are a living one, whose ancestors' scientific achievements, modern instruments have spent the last decade confirming. The next time someone tells you these were primitive peoples who needed outside help to build their pyramids, remember the Venus table. Remember 2 hours of error across 5 centuries. Remember a water filtration system that predates anything in the Old World by 1,800 years. Remember a unified planetary model decoded only last year. Remember that everything we have comes from 4 surviving books out of thousands. Then remember that the people who wrote those books have descendants who are alive, who speak the language, and who do not need you to tell them what their ancestors accomplished. They already know.